Hey everybody, thanks for clicking on this video. Today we're going to be looking with the idea of the binomial theorem. If you want to follow along, the links to the companion worksheet are in the description below. Also, if you want to see more videos like this, click the subscribe button so you can stay up to date on all the videos we have coming out. So let's get started. Now, the idea of the binomial theorem comes to us when we have a binomial, that is something like a plus b, and we're raising that quantity to a power. Now, having done enough algebra, we know how to do this. We can multiply this by saying a plus b times a plus b. So we multiply the first two, which is a squared. The first and the last here, that's ab. And then the inside two, that's a times b. And then finally the last two, which is b squared. And so we get a squared plus 2ab plus b squared. Now, what will be important in a moment that you'll see is I want to highlight the coefficients. What are the numbers here? The numbers are 1, 2, and 1. Now, if we look at the next one, here we want to say a plus b to the third power. Well, really, all that is just taking a plus b times a plus b squared. Now, we already know what this is. We have a plus b times a plus b squared, but we said that that was this quantity, a squared plus 2ab plus b squared. So, what can we do? Well, we can take a and we can multiply that onto everything. So we have a cubed plus 2a squared b plus ab squared. Then we multiply everything by b. So that's a squared b plus 2ab squared plus b cubed. And so if we combine like terms, this term has an a squared b, this term has an a squared b. So we get 3a squared b. And then this term and this term has an ab squared. So that's 3ab squared plus b cubed. Now again, what are the coefficients here? 1, 3, 3, 1. Now if we do one more example, hopefully we'll be able to see what's going on here. So here we want a plus b to the fourth. All right, well that's just a plus b times a plus b cubed, which we just found up here. So that's quantity a plus b times this quantity, a cubed plus 3a squared b plus 3ab squared plus b cubed. So first we'll multiply a onto everything. So that's going to be a to the fourth plus 3a cubed b plus 3a squared b squared plus ab cubed. Then we multiply b onto everything. So that's going to be a cubed b plus 3a squared b squared plus 3ab cubed plus b to the fourth. So now if we combine like terms, we get a cubed b here and a cubed b there. So that's 4a cubed b. And then here we have an a squared b squared and an a squared b squared. So that's 6a squared b squared. And then this is an ab cubed and this is an ab cubed. So that's 4ab cubed plus b to the fourth. So our coefficients are 1, 4, 6, 4, 1. Now notice that the way I'm writing it is very deliberate because we want to write it with one power going down. So here a is first, so a starts with a to the fourth, then a cubed, a squared a, and then it's not there. Whereas b isn't here, but then it's b squared, b cubed, and then ultimately b to the fourth power. Now, if you look here at these two, we have 1, 2, 1, and then 1, 3, 3, 1. Now, both of these start and end with 1. But what about the numbers in the middle? Where do they come from? Well, the 3's come from, well, if I add these two, we get 3. If we add these two, we get 3. So that's how we get this. Now in a similar logic, we have this row of coefficients. We have 1, 4, 6, 4, 1. Now they start and end with 1, but where does the 4, 6, and 4 come from? Well, 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 4 again. So what we have is we have a pattern that we can use to generate these expansions without having to go through all the algebra. And this is the idea of the binomial theorem, is we don't have to go through all this work. What we can do is we can say, all right, this is a plus b to the 5th. So what we would do is we would take the coefficients from a plus b to the 4th and say, what are they going to be here? Well, they'll start with a 1. Then we'll say, what's 1 plus 4? That's 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then it ends with a 1. So what's this going to equal? Well, there's going to be a 1. And we're going to start with a to the 5th because that's the highest power. Plus 5, that's our next coefficient. Now the power of a is going to go down, so it's a to the 4th b. For our next term, the coefficient is 10. And then our power of a goes down again, a cubed b squared. And each time the power of a goes down, the power of b goes up. So the next coefficient is 10, then a squared b cubed. And then this coefficient is 5, a b to the 4th, and then plus b to the 5th. And there it is. There's our work for expanding this out with binomial theorem. As long as we know what the coefficients are, we can continue to expand that. So on the next page, we're going to do that. Here we have a plus b to the 6th power. Well, we take our coefficients that we had above, 1, 5, 10, 10, 5, 1, and we use that to generate the coefficients here. So we start with 1, then we add 1 and 5 to get 6, 5 and 10 to get 15, 10 and 10 to get 20, 5 and 10 to get 15, 5 and 1 to get 6, and then it ends with 1 again. So that means that we're going to start with 1, which we don't need to write, times a to the 6th, plus we have 6, now the power of a goes down, a to the 5th b, plus 15, a to the 4th b squared, plus 20, a cubed b cubed, plus 15, a squared b to the 4th, plus 6a b to the 5th, plus 1, which should be b to the 6th right there. So we just take the coefficients, and we start with the a with the high power, and it goes down, and then b's exponent goes up. So here we have a plus b to the 7th power. So we're going to take this above row and say, what are the coefficients here? They'll start with 1. So 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. And as you notice, you go up and then we go back down. 20 plus 15 is 35. So now it's mirroring itself. 21, 7, 1. So we start with 1 a to the 7th plus 7, and then it's a to the 6th b, plus 21 a to the 5th b squared, plus 35 a to the 4th b cubed, plus 35 a to the 3rd b to the 4th, plus 21 a squared b to the 5th, plus 7 a b to the 6th plus b to the 7th power. And then on our very last example, here we have a plus b to the 8th. So again, we just keep going, figuring out what the next row of coefficients are, and then we apply that. So this will start with a 1, and then 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 and 35 is 70. And then we start going back down. 35 plus 21 is 56. And so I don't have to keep adding. I can just copy the other side. So 28, 8, and 1. All right. So this is going to be a to the 8th plus 8, a to the 7th b, plus 28, a to the 6th b squared, plus 56, a to the 5th b to the 3rd, plus 70, a to the 4th b to the 4th, plus 56, a cubed b to the 5th, plus 28, a squared b to the 6th, plus 8, a b to the 7th, plus b to the 8th power. So this is the general idea. We have our coefficients, and then we start with the highest power on the first part of the binomial, and then that power goes down. The second part of the binomial we multiply, and the power goes up. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.